All right, everyone. So now we're going to dive into question 4. This is probably the worst question on any recent AP exam in terms of student scores. So if this one was particularly difficult, just know you weren't alone. But there are some definite good concepts to take from this FRQ. So let's dive in. Number 1, we want to find the line tangent to the graph of h at t equals 0. So let's go ahead and do that. If we want to find that, we need to know what's going on at 0, and they tell us that at 0 degrees, h is 91. And that means we also need to know the slope at time 0. Now this is a little bit misleading because if you want the slope at time 0, notice your equation for slope actually doesn't involve time, it involves temperature. So we need to use the temperature at time 0. So that could kind of be where the first part of the problem gets a little difficult. Noticing that the slope is related to the actual y value, so to speak, of this equation. When you work this out, 91 minus 27 is 64, and then times negative 1/4 will get you negative 16. Okay, so now we have a point and we have a slope. So y minus y1 equals the slope of x minus x1. That's our equation. Oh wait, there's one thing though. Technically, any line should use y, but we should actually match the independent variable that's used in the problem. So this is going to be our line. We're going to use t instead. And cleaning that up, we have y equals negative 16t plus 91. Awesome, so that's our line. And now they want us to approximate the temperature at 3, so we're going to say that h of 3 is approximately negative 16 times 3 plus 91. And I believe that ends up being 43, because yeah, this is negative 48 plus 91. So 43 degrees Celsius. All right, part B. Part B is a little bit interesting. One thing we might want to do for part B, before we go deriving dh dt a second time, we might actually want to write this as negative h over 4 minus 27, or sorry, plus 27 over 4. In other words, distribute the negative 1/4, because now you're not looking at something that, I don't know, maybe to you has a chain rule aspect going on. This is now just a regular power rule derivative. So when we find the second derivative, when we derive with respect to time, that's key, a second time, well, when we derive h with respect to t, we're just going to get that negative 1/4. Now the power of h is reduced, so it's h to the 0, but don't forget that we also have to have a dh dt because we were deriving with respect to time a second time. And then this plus 27 whatever, that just derives to 0. So we're technically done, but we want to rewrite this now, kind of replacing dh dt with what it was before. So now we have negative 1/4 times the negative 1/4 times h minus 27. And finally, I'm going to rewrite that as 1 over 16 times h minus 27. Okay, so that's the second derivative. And now they want us to use the second derivative to determine if our graph or our estimate is an underestimate over an overestimate from part A. So here's the idea behind this problem. If you look, there's a line up above that says the internal temperature of the potato is greater than 27 for all times t greater than 0. Okay, so here's what we can say about this. Since h is greater than 27 for all t greater than 0, maybe we can see that the second derivative, since this involves 27, if this is always greater than 27, then this is always positive 0. Alright, so the second derivative is greater than 0 for all t greater than 0. Therefore, h is concave up, and so h of 3 approximately being 43 is an overestimate. Okay, so why is it an overestimate? Let's just kind of illustrate this by a picture. If we're looking at a concave up shape here, now remember what we did here essentially, let's call this t equals 0. We made the tangent line t equals 0, and we're approximating what it is at 3. Alright, so in other words, remember that this is the x value 0, this is the x value 3. We move this far, and we're saying how far different are these y values now? And they are vertically spaced, and you can see the actual curve of the graph is above our predicted line. And wherever you were to put your line, so let's say it was somewhere else over here for some reason, and we were predicting, you can see again if I drew this nicely, that my tangent line is always sitting, except for where it is tangent, below the actual graph. So if it's concave up, your tangent line is going to underestimate all the time. And likewise, if it's concave down, your tangent line will rest above in all the other places, so it would be an overestimate. That's what's going on in part B. Okay, last but not least, part C. This is where I actually made my mistake the first time I looked at this question. Unfortunately, this is my second attempt. But my mistake here was solving for C. I just made one little algebra mistake, and I'll tell you where it was. The idea behind this question is they're saying, okay, now there's an alternate model that you could solve for the temperature of the potato. They give you this different function, and now they want you to use this different function to find the temperature at time 3. Now, one thing to kind of take away from this is that even though it's the same prompt, this question especially drives home the point that really almost none of these questions really relate to each other. Like, you actually didn't need to know the answer to part A to get to part B. You don't need A to do B or C. You definitely don't need A or B to do C. So all I'm saying here is don't give up if you don't know what's going on in the first two parts, because hopefully you get to part C and say, oh, this is a separation of variables problem, which should be a little bit easier. So separation of variables, what we're going to do is we're going to move everything involving a g as close as we can to just having g. And it looks like this is about all I can do there. So I'm going to move that whole g term, and then I'm going to keep the negative, and I'm going to keep the dt on the other side. So we've separated the variables. That's step 1. You usually get a point for that. Now it's time to integrate both sides. Usually there's a point for doing that correctly. When you do this, this is technically g minus 27 to the negative 2/3 power normally, if it wasn't in the denominator. So if it's to the negative 2/3 power, I first need to add 1, which means it would actually go to 1/3. So now it's to the 1/3. Okay, now when we derived this, whatever it was, we had to kick down that 1/3. And notice I don't see that anywhere, so there must have been a 3 out front to kind of offset that, because now when I drop the 1/3 down, it disappears to 1, which is what we have going on here. Last thing to think about, there is technically a chain rule going on here, but this inside derives to 1, so we're good. This is the correct antiderivative. On the other side, if we're just deriving essentially negative integral of dt, you're just going to get a t, a negative t, and then you're going to get a plus c. The plus c should go on the independent variable side. Okay, now some people, I think the scoring rubric, I remember looking at it to realize, unfortunately, that I was wrong. They solve for what c is right now. You can totally do that. I just wait to solve for c until the whole problem is already solved for g. So what I'm going to do now is solve for g. So I've got g minus 27 to the 1/3 is negative t over 3, and then I'm going to let that divided by 3 get absorbed by the constant. Now it's just some new constant that was divided by c. Up next, I'm going to cube everything, and my mistake here was I cube rooted both sides again, which was really unfortunate. This whole thing is cubed. Okay, so now I know that g of t is negative t over 3 plus c all cubed plus 27. All right, awesome. So now what I'm going to do is I'm going to solve for c, and they give me that initial condition that at 0 it's 91. So 91 is what I get when I have 0 plus c cubed plus 27. Now essentially this will end up saying c cubed is equal to 64. So what cubed gets you 64? 4 does. Okay, now I know c is 4. And so now we're going to calculate g of 3 because now we know this is really negative 3 over 3 plus 4 cubed plus 27. And when we do that, this is negative 1 plus 4, which is 3. So we have 3 cubed, which is 27 plus 27. So we get g of 3 is, what's 27 plus 27? I think that's 54 degrees Celsius. I think I should also be writing the degree symbol there, but there we go. Maybe not. Okay, so yeah, again, you can see that their approach to the problem is definitely different looking than mine. Again, they decided to solve for c right away, so it wasn't like it was getting absorbed that whole time. But I decided to solve the whole problem for g before I solve for my c. That's just what I do. I would almost recommend it. And then notice here, if you don't include the plus c in general, they're going to limit you to only getting 2 points correct. Now, honestly, I don't even know what else you could do if you don't separate the variables, so I don't think that's the worry. But yeah, so 1 point for separating, 1 point for anti-deriving, 1 point for using the constant of integration and getting that initial condition, 1 point for solving it for g and t. So in other words, when I solve this whole thing for g and t before I solve, that's technically a point in the problem, just getting g and t totally isolated. And then we have a g of t and g of 3. So a lot of points to be had in this question. I think it's actually not as bad once you see it fully solved. Just some of the wording somehow really got to people the first time they saw it.